Hi, welcome back. Today we talk about top design with functions in C programming. The outline of the presentation is as follows. We'll have introduction to functions, then we talk about some predefined functions and standard library functions and how to make the use of the code. So let's have an idea about functions in C programming. So far we have learned how to use operators and how to use the percent for the input formatting and for using simple arithmetic functions also. However, we are not able to write full mathematical functions until we start using them in fully working code. For example, we cannot yet represent any of the following expressions in C programming: the square root, the absolute value, a ratio with the power, or logarithm of specific number. So, C programming doesn't have any operators to perform square rooting, or give you the absolute value, or get you the sign or a log, or something like that. However, C programming provides you with functions. These are provided in standard library, or could be easily defined functions that will carry out such arithmetic and mathematical functions. So a function in C programming can be thought of a block of code that will take some input, one or many inputs, and that might produce a single or no output. So at the beginning, we might think of this like a black box, which has some inputs, a set of inputs, and it might produce or not an output. So for example, in the following, we are going to show some standard math libraries. The square root. So if you look at the square root, it takes an input. So here, it will be only one arrow as an input, and it produces an output which is stored through assignment operation. For example, if x is equal to 16, the square root would be 4.0, which will be then assigned to variable y. So in this expression, we have made two steps. The first step is a function call to the square root, where we have passed an argument of value x, and then the assignment operation, which is assigning the result of the square root to the variable y. For example, we could have done another assignment. Now we have an addition operation between a constant 5.7 with a function call. So the result of the function call to square root, given the input of w, will be returned and will be used as second operand in the addition operation, and then the overall result will be stored in variable z. So if w is equal to 9, z will be assigned 5.7 by 3, which is 8.7. So having a look at this, we might see the square root function like a black box, which has a set of instructions in C or any other language that will do some commutations for the square root. So given an input, which is indicated by an ingoing arrow, which is x is equal to 16, and then the black box which is here, will produce a result which is 4.0. So without going into details how the square root was performed, we know that these are a set of instructions that are already provided by standard library in C that will allow you to do square root computations. So this is another example. So we are trying to make the computations of 3 square roots. As you can see, these are the comments we were talking about last time, which mentions that providing a comment will allow the user or the programmer to understand the purpose of the code you are writing. And then notice the include statements for the preprocessor, where you are stating that we need to do 2 import statements, very important for us. The first one is stdio.h, which is for the standard input-output operations for using printf and scanf, and the other one is the math.h, which is the main library for using the square root. In the main function, using the same paradigm, we are declaring 2 variables, first and second, and then we are declaring another variable called first square root, second square root, and sum of the square root. So basically, our code will read from the user 2 inputs. One will be stored in the first, the other one will be stored in second, and then we make a function call to the square root to compute the square root of the first input and the square root of the second input, and finally we'll sum up the square root of the 2 inputs and store them in a variable called sum_sqrt. So as you can see, we are providing again comments for the programmer or any other code user to understand the purpose of each statement. So there is a prompt. First of all, we provide a prompt for the user. So we ask him to enter the first number, then we read using the placeholder %lf for double, and we store it in variable first, and then we make a function call to sqrt by passing the argument first, and then the result will be stored through assignment to the variable first sqrt. We do the same thing for the second, and then we do summations. As you can see, after completing the call and doing the assignment, we are printing to the user the result of our computations by using a placeholder of 0.2f, meaning that the result will be displayed only using 2 decimals. And then we do the same thing for the second input, the same prompt for the user, then we scan the input, then we do the function call to SQRT, then we print the result. After that, we call a third time the square SQRT function by passing as an argument first and second values. So we are doing an arithmetic operation of addition. Then the result of this arithmetic operation, first plus second, will be passed as an argument to the function SQRT, and the result finally will be stored in variable sum underscore SQRT, and finally the result will be displayed to the user again using 2 decimals. And finally, we write the return statement using this argument 0, stating that everything has gone okay and the code is completing and successfully. As you can see in these few lines, we are showing a sample execution of the code which is being written above. So, as first input, the user has entered, for example, 9, then the square root is 3. Notice we are printing on 2 decimals, and then the user is entering 16. So again, printing on 2 decimals, we are printing the square root, 14, and then of course 4.7. 4, 9 plus 16 will get 25, and the square root of 25 is 5. Predefined functions and code reuse. As we have seen simple example with the square root, we have used standard library functions. So we didn't write these functions, we just made use of them by calling these functions from the standard library. So the primary goal of software engineering is to write error-free code. However, we should make sure that we are going to use some code that is already written and well tested. So we want you to achieve something like while reinvent the wheel. So make use of available things that are reliable, and then we proceed and improve further our code. So C programming language promotes the reuse by providing many predefined functions. Example given, we have mathematical computations, input, output, printf, scanf, square root, apps, max, and so on. In the next few slides, we are going to look at some commonly used mathematical functions. So in order to use this function, for example, from the math library, we have to use include statement for the preprocessor command to mention the appropriate library. For example, to use SQRT, we have to include the math.h library. So a function code with numeric argument that is not on the argument type list, the argument value is converted to the required type before its use, which is kind of casting. So basically, conversion type of int to type double cause no problems. However, converting from double to type leads to the loss of fractional path, which is mainly a warning like precision loss, may be lost. So make sure that you look at documentation of the functions so you make use of them correctly and you pass the argument with the right types. So now let's look at some mathematical library functions. In this table, we see some functions. For example, the apps, it's in the standard library.h. The floating absolute value is in math.h. The sine, the cosine, the tan in the math.h. The log in the math.h. The log10 in the math.h. The power, where you get number value x raised to the power y in the math.h, and the square root in the math.h. So basically, these are the purpose of these functions, and then we have to look very carefully at the input and the output arguments, because that's the way to make sure that you make the call with the right and appropriate input and output types. An example. Let's look at an example in this slide. We could use C functions pow and square root to compute the roots of quadratic equation in x of the form. So if you have x squared plus bx plus c equal to 0, so we know that discriminant is equal to b squared minus 4ac. If it's greater than 0, then the two roots are given by minus b plus square root of b squared minus 4ac over 2a, and the second root is given by minus b minus square root of b squared minus 4ac over 2a. So as you can see, we could make use of some terms which are the same. So you could use the use of square root of b squared minus 4ac is the same term repeated twice. So using these two roots of the quadratic function, we could find the first root in this way. So we are using the power. We know that the b storing the p of the second term of the equation. So b raised to the power 2 minus 4 times, remember the star that to note the multiplication in C, so minus 4 star A star C. So basically it stands for minus 4AC. So B squared minus 4AC, and then we are putting it in the discriminant variable, and then of course the root 1 is equal to minus B plus square root of the discriminant over 2A. Notice again that the division, and then we are using some sub expression to avoid any misleading commutations, because if you don't do the sub expressions, what happens? This square root of this will be divided by 2, which will lead to the wrong result. Same thing, the square root of the second root is given by minus b minus square root of this discriminant. We are making again a call to the function sqrt over to a.